In this lesson, we're going to talk about transformations of a parabola for a quadratic equation. Let's take a look at some notes. If we start with a basic quadratic equation, which would be y equals x squared, which is shown to the right, notice the vertex is at 0, 0. So what we want to look at is just in general, when you have a quadratic equation, what happens if we add a number to it, or if we subtract a number from x squared, how does that affect the parabola? So let's take a look at a couple of situations so that we can see what happens to the graph when we add or subtract a number to the x squared. In this first problem, y equals x squared or negative x squared plus 2, I'm going to first just kind of sketch y equals x squared in blue. So y equals x squared looks something like this. So the question is, if we start with y equals x squared, there's two things that have changed in this new equation. Number one, we've added a 2, and the other thing is the x squared is now negative. First, let's address the negative. When a is negative in a quadratic equation, in other words, when the number in front of the x squared is negative, what that does is that flips the parabola over, so now it's facing downwards. So let me draw that in red. So that's just y equals negative x squared. It just flips it down. So negative means that it opens downward. Now the plus 2 means it's going to shift up 2 on the y-axis. So in other words, the plus 2 is the y-intercept. So the actual graph, which I'm going to do in green, is going to shift this red one up 2 spaces. So it's now going to cut through the y-axis at 2. So it's going to look something like this. Okay, so two things happened in this one. Number one, the parabola flipped down. And number two, the y-intercept is now 2. So it moved up. In the second problem, going from y equals x squared to y equals x squared plus 3 is a simple transformation. So again, y equals x squared means the vertex is at the origin. Now, this one's not going to flip over because notice the a, or the number in front of x squared, is still positive. So all that's going to happen is we're going to change the y-intercept to 3. So in other words, this parabola is going to shift up 3 places. So the new parabola will now have a y-intercept of 3, and we'll now sketch what it would look like. So in these two examples, if we were to identify one similarity and one difference in their graphs, what do you think it would be? Definitely the difference is obvious. Obviously, one of the graphs is flipped downward and one of them is flipped upward. So that's the difference. The similarity, I would say, would be in their y-intercepts. Although they have different y-intercepts, because one is at 2 and the other is at 3, both y-intercepts are above the y-axis. I'm sorry, above the origin. Let's take a look at some more examples. Okay, in these two problems, we've added one more element to the equations. We've added a number in front of the x squared. And that's actually going to change a part of the parabola. It's going to change the width. Sometimes you'll see it's going to be a little narrower, and then sometimes it's going to be wider than our original parabola for y equals x squared. When it gets narrower like this first one, we say it's stretched vertically. So think about stretching your arms up in the air. Okay, it's going to get skinnier. So this means we're stretching the parabola. On the other hand, if we're widening the parabola, we say it's becoming compressed. So compressed and stretched. Stretch would be like your arm stretched in the air. It's getting skinnier. Compressed means it's getting wider. And the way that you know if it's going to stretch or compress is based on the number in front of the x squared. So basically, if that number is a fraction, it's going to become more compressed. If that number is not a fraction, it's an integer, then it's going to be stretched. So if you always start with y equals x squared. So if this were y equals x squared in blue, a couple things are going to happen. Notice the negative sign, so we know it's going to be flipped upside down. The 5 tells us it's going to be stretched, so it's going to be skinnier. And then the 2 tells us the y-intercept will be at 2. You have to start at the y-intercept. So let me put the y-intercept in red. Now I know it's going to be flipped down and it's going to be skinnier than my original blue parabola, which is y equals x squared. So I'm going to flip it down, and this is just a sketch. And notice it's skinnier. Okay, so if you were describing the transformations, you could say the y-intercept, or the parabola shifted up 2 places, has a new y-intercept of 2. It flipped downward, and it stretched vertically, which just means it became skinnier. In number 4, again, start with the y-intercept and put that on the graph. So the y-intercept is -3. This one also is negative, so it's going to flip down compared to our graph of y equals x squared. Now, because a fraction is in front, that actually widens the graph. So we're going to flip it down, but we're going to make it wider than what our original graph of y equals x squared is. Okay, so one similarity between these two graphs would be they both flip downward, and two differences would be number 1, for graph in number 3, the y-intercept is above the origin, and in number 4, it's below the origin if you look at the red graphs, or the red parabolas. The other difference would be the graph of number 3 is stretched vertically, where the graph in number 4 is compressed vertically. Let's take a look at a few more. In this particular problem, we're going to identify the similarities and differences between the graphs of these two equations, but notice we don't even have a graph to use. So let's see what our options are. Let's look at A and B. It says parabola has a maximum or a minimum. So a maximum means it goes upside down, because that means it's got a high point. That's a maximum. A minimum means it's opened upward, because it has a low point. So remember, that's going to be determined by the A. So look back at the equations and notice in equation A, it's negative. So that means it's going to be opened downward, where in B, it's going to be opened upward. So when we look at the Venn diagram here, and here's equation A and equation B, we're going to place the letters from the right into the correct sections in the Venn diagram. So equation A, it's going to have a maximum, so we're going to put an A in there because A represents the maximum. Where equation B has a minimum, so we're going to put a B in that circle. Then anything they have in common, we're going to put in the center. So any similarities go in the center. Okay, if you look at C and D, it says y-intercept is below the origin and y-intercept is above the origin. So that's based on the C value, the -8 and the -3. So if it's -8 and -3, notice they're going to be both below the origin. So that's something they have in common. Neither of them are going to have a y-intercept above the origin. So we're going to put a C in the middle, showing they have that in common. Now let's skip E and F for a moment and jump down to G and H. Parabola is compressed. parabola is stretched. To be compressed, we want to look for that fraction for a. To be stretched, we want to look for an integer, which means a positive and negative number, but not a fraction. Okay, so if you look at equation A, notice there's a -5. Since that's an integer, that's going to be more stretched, so that would be h. So for in the first circle for equation A, we're going to put an h. The second equation has a fraction of 1/4, so that's going to be compressed, which means it's going to be wider. So we're going to put a g in equation B's circle, which leaves us with these last two, E and F. It says vertex is located right of the y-axis versus vertex is located left of the y-axis. Well, we don't know the vertex of these equations. So let me erase this information up here right now. Remember, to find the vertex, you need -b over 2a. We really only have to worry about the x value of the vertex, because think about it, if the x value is a negative number and you were to graph it, it's going to end up being to the left of the y-axis. But if the vertex, the x value of the vertex is positive, and you graph it, it will end up being to the right of the y-axis. So all you need to really know is the sign of the vertex. So you just have to quickly plug in the b, and then in the denominator the a, and really just look at the signs. It comes out to be -2/10 or -1/5, but the point is it comes out to be negative for the first one. So if you graph any vertex or any point with a negative x value, negative numbers are all to the left of the y-axis, which is choice F. So for A, we're going to put an F in that circle. Let's see for the second one. Okay, so it's going to be -6 over 2 times a fourth. Now, it doesn't matter. You don't have to do the calculation for the fractions. Just look at the sign. You've got a negative on top and a positive on the bottom, and a negative divided by a positive is a negative. So they both actually, because they're both negative x values of the vertex, they're both going to have a vertex that's located to the left of the y-axis. So I'm going to erase the f over here in equation A's circle and put that in the center because they share that in common. Okay, so just to recap real quick, remember the A's, so the -5 and the 4, if they're negative, it opens downward. If it's positive, it opens upward, the parabola. If it's an integer, it's going to be vertically stretched, which means skinnier. If it's a fraction, it's going to be wider. And then if you look at the end of each equation, the c values, those are the y-intercepts. So since they're both negative, they will graph below the origin. If they would have been both positive or one of them positive, it would have graphed the y-intercept above the origin. And then to determine the vertex, you actually have to plug at least the signs into the vertex formula for x. And if the sign of the x value of the vertex comes out negative, it's going to be located to the left of the y-axis. If it comes out positive, it will be located to the right of the y-axis. And that completes the lesson on transformations of parabolas for quadratic equations.